the fastest spacecraft ever to leave Earth, a 9-year marathon covering 3 billion miles, to reach a mysterious world hidden in deep space. Is it alive or completely frozen? They have only one shot to get it right, so there'll be a little bit of tension in the air. Through unknown danger, if New Horizons were to hit something as small as a grain of rice, we'd be done. History will be made, and we are there. We've hit the motherlode of fascinating objects on this mission. Our destination is Pluto and the Kuiper Belt beyond. This Atlas V rocket is about to launch a very special mission. 3, 2, 1. We have ignition and liftoff. This is the New Horizons spacecraft. It's on a voyage to the last unexplored planet in our solar system, Pluto. But nearly 2/3 of its journey is spent in suspended animation. All instruments not essential to navigation and flight control are turned off. This preserves the battery and reduces wear on the equipment. New Horizons has taken 18 naps since launch, each lasting from 36 to 202 days. That's roughly 2 in-flight naps per year. During each nap, the spacecraft sends a beacon tone once a week to let its team back on Earth know that everything is okay. But this is the last nap New Horizons will take before it makes history. We really have never been to a planet like Pluto before. It is the farthest footfall any humans have ever made on another shore, exploring a small planet 3 billion miles from Earth. It's an incredibly pristine body. It has experienced relatively little evolution over the 4.5 billion years the solar system has existed. It is a geologic time capsule. Pluto is a linchpin for understanding how our solar system formed. Some of the most important questions we can ask as 21st century planetary scientists are about how the Pluto system was created. A clue might be found in Pluto's oversized moon, Charon, about the size of Texas and roughly 10% the mass of Pluto itself. Its huge size suggests something violent about Pluto's formation. The best models we have indicate that Charon was born in a titanic collision between Pluto and another planet that smashed into it billions of years ago. The impact blasted material into orbit that eventually coalesced to form Charon and probably the other small moons as well. Pluto marks the inner boundary of a vast realm at the edge of our solar system, populated by chunks of ice and rock. Some are as large as Pluto itself, so it's most likely that these icy worlds, like Pluto, are objects that formed in great numbers in the outer solar system. Most are gone today, for one reason or another. The ones we see now are the surviving relics of a much larger population. New Horizons is mankind's first reconnaissance of this outer region of our solar system. Pluto is the probe's first destination. We are roughly 4.5 months away. When we pass through the Pluto system, we're going to get in very close, closer than any of its moon's orbit. In fact, we'll pass about halfway between Charon's orbit and Pluto itself. We'll be right down among them, collecting great data the whole way. New Horizons has a long to-do list, but its goals are simple. Reveal the geology and landforms of Pluto and Charon, map the surface composition, analyze the atmosphere, and determine its escape rate. What kinds of geological features are on the surface? Is it still active with eruptions, tectonics, or volcanism, or is it completely shut down and frozen? Ever since its discovery, Pluto has been a place of mystery. In 1929, a Kansas farm boy with a talent for building homemade telescopes starts a new job at the Lowell Observatory near Flagstaff, Arizona. That farm boy is Clyde Tombaugh, and his task is to find a hypothetical planet thought to exist beyond Neptune. He uses a machine called a blink comparator. It lets him compare images taken on different nights. Any object that moves between images isn't a star, it's a planet. In 1930, Tombaugh discovers Planet X. At the suggestion of an 11-year-old English girl named Venetia Burney, it is named Pluto, after the Roman god of the underworld. For the next 75 years, Pluto is classified as the 9th planet. Then in 2006, the New Horizons mission launches. But just 6 months later, a strange controversy begins that challenges our very idea of what a planet is. This gets into the whole debate about whether Pluto is a planet or not. Pluto has been labeled a dwarf planet. In 2006, it was reclassified in the eyes of some demoted. A controversy is born. People ask me about this all the time. The first thing I tell them is that it was really started by people who are not experts in the field. Most people think astronomers and planetary scientists are the same. That's only true in the sense that a dentist and a brain surgeon are both doctors. Really, most astronomers don't know very much about planets. They're not experts. They don't attend the technical meetings. So the controversy was started by non-experts who happened to get the microphone. I think an object should be classified as a planet based on its intrinsic properties, not its location. Pluto was demoted because of where it is. Its orbit crosses Neptune's. According to the IAU definition, a planet must have cleared its orbital neighborhood. Since Pluto hasn't cleared Neptune, it's not a planet. But if you put Earth where Pluto is, Earth wouldn't be a planet either. That tells you there's something wrong with the definition. What fuels the controversy even more is the growing number of planet-sized bodies beyond Pluto. At least one is bigger than Pluto. Is it a planet too? We thought there were only 9, but the real number is probably closer to 900 planets in our solar system. But the debate about Pluto's status is a double-edged sword. In some ways it's helpful because it gets people interested in astronomy and planetary science. They start asking themselves, is Pluto a planet by my own criteria? The unfortunate part is what happened in Prague in 2006. They took a vote. The recommendation was that we consider Pluto to be in a special class. More than 2,500 astronomers attended that meeting of the International Astronomical Union. But by the time the vote happened, most had already left. Less than 17% of the attendees actually voted. Votes don't work very well in science. For many people, it convinced them that science is arbitrary, that things like evolution or climate change are decided by voting instead of by data. It should never have happened. I think it set science back. It may have been the worst pedagogical moment for science in recent decades. It's hard to imagine that exploring a planet at the far end of our solar system could create such turmoil here on Earth. New Horizons is already on its final approach. A lot has changed since that fiery liftoff 9 years ago. Then there's the discovery of Pluto's small moons and the realization that Pluto may be surrounded by uncharted hazards. In fact, Pluto is now dead ahead. For the first time in history, Pluto is no longer just a dot. On April 9th, the onboard cameras captured the first color image ever taken of the Pluto system by a spacecraft on approach. Even at this distance, distinct differences can be seen. Images taken in early to mid-April from within 70 million miles already show broad surface markings. LOL uses less power than a string of Christmas lights, yet captures images in black and white. Ralph is the color camera that can shoot in light levels 1,000 times dimmer than on Earth, allowing it to map Pluto's night side. Ralph can also see in infrared like night vision goggles and act as a spectrograph to reveal what the surface is made of. But 2 more instruments will let us sniff the air and even taste it. Pepsi will serve as our extended nose. SWAP looks at how solar wind interacts with the atmosphere. About 10 weeks before arrival, we'll beat Hubble's resolution, and it will only get better. This turns the encounter from a quick visit into a long study of the Pluto system. Before New Horizons, our best views came from Hubble images processed by Mark Buoy. As the spacecraft crosses nearly 1 million miles a day, the pictures get clearer. What we see are different light and dark regions caused by variations in the planet's albedo, how much light the surface reflects. There's a big dark region we've known about for a long time, covered with carbon-rich material. There's also the brightest region on the planet, rich in carbon monoxide ice. Buoy's maps guided the mission planners toward a trajectory that passes over that large, bright patch. Every day the images get sharper, history is being made. New Horizons is 60 million kilometers from its target and closing fast. All systems are working. Sending a probe on a decade-long journey 3 billion miles away is one of the crowning achievements of the space age. It began in the 1950s, and through advancing technology, we've opened up the solar system for the first time. As Carl Sagan said, only 1 or 2 generations get to be the first to Mars, the first to Venus, the first to turn points of light into real worlds. No new planet had been visited since Voyager 2 passed Neptune, yet one world remained tucked away in the history books. As New Horizons closes in, a new discovery brings sudden danger. When we found Pluto's small moons, we realized they get hit by tiny debris as the system moves through the Kuiper belt. Because the moons have almost no gravity, the material blasted out of craters doesn't fall back, it goes into orbit around Pluto. We can't see it, but it poses a hazard. Even a grain of rice hitting us at this speed could destroy the spacecraft. A hazard team is formed to search for any dangerous rubble in the flight path. The danger lies in the unseen, whether the size of a car or a grain of sand. New Horizons is speeding along at over 1.2 million kilometers per day. Strike anything at that speed and it's game over. Despite the risk, the odds look good. There's almost no chance of being hit, but we are flying into the unknown. The safest path is right through the heart of the Pluto system, but the team stays ready. If they spot danger, they can turn the spacecraft so the antenna faces forward for extra protection. For many, the next few days will be tense. Then it happened. Contact with New Horizons is lost. Mission controllers scramble to diagnose the problem. Some 90 minutes later, a signal is detected, but not from the main computer. The main computer had overloaded while compressing data and uploading commands. The backup computer put the spacecraft into safe mode. Some data was lost, but the highest priority science is unaffected. It takes 2 days to recover the main computer. Now the team is back in action. New Horizons is doing great. It's right on course and all instruments are performing perfectly. We're getting great data. After a journey of 9.5 years, with 5 days until flyby, New Horizons is arriving at its destination. The intensive exploration phase is a 9-day plan that runs from July 7th to the 15th. The spacecraft is working as hard as it can. On final approach, the probe becomes fully autonomous, monitoring everything, compressing data, and tracking the planet. Back on Earth, a huge crowd gathers at mission control, anxiously waiting for closest approach when the spacecraft will be just 7,700 miles above Pluto's surface. New Horizons sweeps past the planet, continues making observations, then begins to move away. It will only pause briefly to send a quick engineering signal telling us it survived and is healthy. That signal will reach Earth around 9 p.m. Eastern Time. There'll be a little bit of tension in the air, that's only normal. And then it came. We are in lock with telemetry. The spacecraft is healthy. We have recorded the expected data of the Pluto system, and we are outbound. The New Horizons team has gone where no human has gone before. Finally, the pictures begin to come in. Pluto becomes a known world. High-resolution images reveal stunning detail. We see a heart-shaped region, now unofficially called Tombau Regio. Along its edge lies the vast frozen plain known as Sputnik Planitia. Glaciers of nitrogen ice flow along crater walls. There's a sudden mountain range, Al Idrisi Montes, towering mountains of water ice rising 11,000 feet high. Pluto's moons surprise everyone. Charon has an unexpected dark polar cap and a massive chasm. Hydra is strangely bright. We see exposed water ice, complex geology, and strange ridges unlike anything else in the solar system. 24 hours after the flyby, New Horizons captures a spectacular backlit image of Pluto's extended atmosphere. Data continues streaming back. It will take 16 months to download everything. New Horizons is now heading toward its next target in the Kuiper Belt, a small world called PT-1. The rendezvous is set for January 2019. With its successful exploration of Pluto and the Kuiper Belt, New Horizons is giving us a glimpse of our own origins and showing what human curiosity and determination can achieve.